Hi everybody! Today we are going to learn how to multiply terms with exponents. So we're going to see if we can actually come up with our own rule for multiplying terms with exponents, and we're going to do that by expanding the terms and looking for patterns. So in this first example we have x cubed times x squared. So we know that x cubed is just x times x times x. Remember, the exponent tells us how many times we've multiplied that term. And then x squared is x times x. So if you combine all of those together, you can see that we're multiplying x together 5 times. So this is just x to the 5th. Okay, so that means x cubed times x squared is x to the 5th. Let's try this next example. Here's just a single y times y squared, which means y times y. And then we have times another y. So if you count how many times we're multiplying y, it's 4 times, which means we can write y to the 4th power as our final answer. Here we're multiplying with base 2, so we're multiplying 2 4 times and then 3 more times. So it's 2 times 2 times 2 times 2, and then times 2 times 2 times 2. So remember, this 2 to the 4th power is this, 2 cubed is this, and it's all being multiplied. You'll notice that we're multiplying it 7 times, so it's 2 to the power of 7. And then here, first we have our coefficient, so let's just do one part at a time. 3 times 2 is just 6. And then let's see how many x's we have. So we have x squared, which is x times x. And then we have another x here. And then we have y and y cubed. So that gives us y times y times y times y. And that leaves us with 6. I have multiplied x 3 times, so that's x cubed. And I've multiplied y 4 times, so that's y to the 4th. So it's okay to expand out your terms and then count how many times you've multiplied to get your answer. But it'd be great if there were a quicker way to do that, because what if we had a really large exponent like 100? You wouldn't want to write it out 100 times. So if you look for a pattern here, you'll notice that our answer is always the exponents added up. So here 3 plus 2 is 5, 1 plus 2 plus 1 is 4. Remember, if we don't see an exponent, we can put an invisible 1 there. If you look at the next one, 4 plus 3 is 7. Here, 2 plus 1 is 3, and 1 plus 3 is 4. So this can be a shortcut for us. So if we want to generalize a rule for multiplying with exponents, first we have to note that the base must be the same. All you have to do is add up the exponents, and that will save you some time rather than expanding out the term and then counting. So remember, when you're multiplying with exponents, you just add up the powers. There is a special rule. Any base to the power of 0 will always equal 1. So we'll just replace it with a 1. Even if it had a variable, any base to the power of 0 is 1. All right, let's give a few of these a try. So remember, our rule is if the base is the same, we add up the exponents. So for this first problem, we're going to do one variable at a time. So let's start with our m variable. If I add up the exponents, I have a 5 here, and when we don't see an exponent, we treat it as a 1. So it's going to be 5 plus 1. And for our n's, it's going to be 3 plus negative 3. So 5 plus 1 is 6, so m to the 6th power. And then n to the 0 power. Remember, anything to the 0 power becomes 1, so it essentially will disappear because multiplying by 1 doesn't change anything. So our answer is m to the power of 6. All right, for the second one, we have the same base, so we can add up the exponents. So we have 4 to the power of 3 plus 3, which is just 4 to the power of 6. Okay, for this next one, let's do one at a time. We can do 5 times 3. We know 5 times 3 is 15. And now let's do x. Here we'll have 1 plus 1, which is 2, so x squared. Now we can do our y's. Again, we will have 1 plus 1, which is 2. And then the z's, which again, we have 1 plus 1, which is 2. And that's our answer, 15 x squared, y squared, z squared. Okay, let's do this last one. Here, if I'm going in order, I'll start with A's. However, you'll see that I only have an A term here. So it's going to stay the same, A to the 8th power. Now let's do our B's. I see we have -3 plus 9. Now let's do C's. Here we have 6 plus 9. 6 plus 10. So here we have 6 plus 10. And for the D variable, we only have one here, so that will stay the same. That'll be D to the power of 5. So if you simplify that, that becomes A to the 8th power, B to the 6th power, C to the 16th power, and D to the 5th power, all multiplied together. Okay, go ahead and pause the video and give these 4 a try. We'll check our answers in just a moment. Okay, so go ahead and check your answers here. Here, 4 plus 6 is 10, so x to the power of 10, y cubed is unchanged. 7 plus 2 is 9, so 3 to the power of 9. Here, when we add up 2 and -2, it becomes 0, so this term is going to disappear. And then we have 3 plus 1, which is 4, 1 plus 1, which is 2, and of course, -2 times 8 is -16. Then here, 22 plus -9 is 13. This is the only B term, so it stays the same. 15 plus 5 is 20, and 15 plus 11 is 26. So the last thing we're going to talk about is what happens if you have a negative exponent. So if you have a negative exponent, I like to say just flip it. We're never going to leave our final answer with a negative exponent. So you find the part that's negative, and you're going to flip that specific part either from the top to the bottom of a fraction or from the bottom to the top. So for example, if you have a to the power of -5, think of it as a to the power of -5 over 1. This is going to flip to the bottom, so it becomes 1 over a to the power of +5. So once it flips, the negative sign disappears. So this, we would never leave our final answer like this. We would write it like this. Now here, we have 1 over y to the -3. So we're going to flip it from the bottom to the top. So it becomes y to the power of +3 over 1, or we could just leave it like this. For the last part, notice that there are some terms that have positive exponents and some that have negatives. So we only flip ones that have negative exponents. So we want to flip the y and we want to flip the a. The 4 can stay on top, x cubed can stay on top, and z to the 5th can actually stay on the bottom. But the y needs to move to the bottom and the a needs to move to the top. So that will leave us with 4x cubed, a cubed. Once I flip it, it becomes positive. Z to the 5th stays where it is, and y squared moves and is now positive. That's how we would write our final answer. So we're just going to try 2 more together that might have negative exponents so we can practice writing it with our final answer. So here, let's use our rules. When the bases are the same, we add the exponents. So 5 plus -9. And 5 plus -9 is x to the power of -4. And we don't want to leave it with a negative exponent. So we're going to flip it to the bottom. And we can't leave nothing on top. That's why we put a 1 there. So it becomes 1 over x to the power of 4. So that's how we'll write our final answer. All right, last one together. Here we have x, and our exponents are 1 and -4. So we're going to add them up. 1 plus -4. And then we have y with the exponents 3 and 1, so y to the power of 3 plus 1, which leaves us with x to the power of -3, y to the power of 4. So you'll see here that we have one of our variables with a negative exponent, so only this term is going to move to the bottom. So our final answer will be y to the power of 4 over x cubed. So our x term only has moved to the bottom. Since y has a positive exponent, we're going to leave it where it is in the numerator. All right, that is all for today's lesson. Thank you so much for watching.